Now limit x tends to 0, tan inverse x upon x is 1. Now x is this term. So what we have to do? Multiply and divide by this term. So in the next step, we will write it as h upon 4 plus root 3h multiply by h upon 4 plus root 3h plus tan inverse root 3. Now this is equals to 1. So limit h tends to 0, root 3 by h into 1, h upon 4 plus root 3h plus tan inverse root 3. This h will get cancelled. Now put the limits. 4 plus 0 plus tan inverse root 3. So what we get? Root 3 by 4 plus tan inverse root 3. Root 3 by 4 plus tan inverse root 3. Note it down. Now the next one is f of x is x into e power x. So f of x plus h will be x plus h e power x plus h. So put the value here. Limit h tends to 0, x plus h ex plus h minus x ex upon h. Now in the next step we can write it as limit h tends to 0, x into ex into eh, h into ex plus h. From these two terms take x into ex common. Limit h tends to 0, x ex, eh minus 1 upon h plus limit h tends to 0, h ex plus h upon h. हमने टर्म्स को सेपरेट भी कर दिया. Now limit x tends to 0, ex minus 1 upon x is 1, so this is equals to 1. X ex into 1, h will get cancelled here. Put the value of h here, ex plus 0. So x ex into ex, powers will add e to x. Here we have plus sign, not the multiplication. X ex plus ex, take ex common, x plus 1. Ex into x plus 1. Now the next one is f of x is equals to cos inverse 2x plus 3. Cos inverse 2x plus h plus 3. Now put the values here. Limit h tends to 0, cos inverse 2x plus 2h plus 3 minus cos inverse 2x plus 3 upon h. Cos inverse is equals to pi by 2 minus sin inverse. So put here the value. Cos inverse as pi by 2 minus sin inverse 2x plus 2h plus 3 minus pi by 2 minus sin inverse 2x plus 3 upon h. Pi by 2 will get cancelled here. So we have left with the term sin inverse 2x plus 3 minus sin inverse 2x minus sine inverse y, that is equals to sine inverse x into square root of 1 minus y square minus y into square root of 1 minus x square. Use this formula here. We get limit h tends to 0, sine inverse x is 2x plus 3, 1 minus y square, square of this term 2x plus 2h plus 3 whole square minus y is 2x plus 2h plus 3 square root of 1 minus 2x plus 3 whole square upon h. This is what we get here. Let this whole term as z, limit h tends to 0, sine inverse z upon h. We know that sine inverse x upon x is 1, so we have to multiply and divide by z here, where z is this term. So this, it becomes 1. If h tends to 0, then z will also tends to 0. So here put the value, this is equals to 1, limit h tends to 0, put the value of z here, 2x plus 3, 1 minus 2x plus 2h plus 3 whole square minus 2x plus 2h plus 3 square root of 1 minus 2x plus 3 whole square upon h. So in the next step, what we have to do, rationalize this. So in the next step, we get limit h tends to 0. When we rationalize it, a minus b, a plus b is a square minus b square. So here we get in the numerator, this square of this is 1 minus 2x plus 2h plus 3 square minus a square minus b square 1 minus 2x plus 3 whole square upon h into this term with opposite sign 2x plus 3 1 minus 2x plus 2h plus 3 whole square plus 2x plus 2h plus 3 1 minus 2x plus 3 whole square. Is it clear up to here to everyone? Clear? Now in the next step, solve the term. For simplification of this term, let this term as y and this as z. Y 1 minus z square minus z square 1 minus y square. Let this term as y and this as z to easily simplify it. So multiply y square minus y square z square minus minus plus. So it will get cancelled. We have left with y square minus z square. What was y? 2x plus 3 whole square and z was 2x plus 3 plus 2h whole square. Now open the brackets. A square plus b square 2ab a square plus b square plus c square 2ab 2bc 2ca. So 4x square will get cancelled, plus 9 and 12x. So we have left with the term minus 4h square minus 12h minus 8xh. Take h common. So we have left with 4h plus 12 minus 8x. So this is the simplification जो हमने क्वेश्चन में यूज करी है. Note it down. Plus 3 whole square and h upon the denominator term will remain same. Limit h tends to 0. After solving this, what we get? h into the term in the denominator. Limit h tends to 0. Minus 4h square minus 12h minus 8xh, h upon the term in the denominator. Now take h common from here. We have left with 4h minus 12 minus 8x. It will get cancelled. Now put the limits. H tends to 0, minus 12 minus 8x. Term in the denominator is 2x plus 3. 1 minus h is 0. 2x plus 3 whole square plus 2x plus 3. 1 minus 2x plus 3 whole square. So twice this term in the denominator. Two times 2x plus 3, 1 minus 2x plus 3 whole square, 2 common, 2 will get cancelled. So this is the, if we take 2 again common from here, 2x plus 3, 2x plus 3, 2x plus 3 will get cancelled. Now we have left with minus 2 upon 1 minus 2x plus 3 whole square. Now the next one is log of sec of x. So f of x plus h is log of sec x plus h. Now we can write it as limit h tends to 0, log of sec x plus h minus log of sec x upon h. Use the formula here, log a minus log b, log a upon b. We don't add, limit x tends to 0, log of 1 plus x upon x is 1. So add and subtract here 1. So we write it as limit h tends to 0, log of 1 plus, take LCM here, sec x plus h. We can write it in the form of cos. 1 sec x is cos x upon cos x plus h minus 1 upon h. Now take the LCM. Limit h tends to 0, log of 1 plus cos of x minus cos x plus h upon cos of x. This is log of 1 plus x. So we have to multiply and divide by this term, cos x minus cos x plus h upon cos of x, cos x minus cos x plus h upon h into cos of x. Now log 1 plus x upon x, that is equals to 1. So 1 into limit h tends to 0. Now here apply the formula for cos c minus cos d. Cos c minus cos d, that is equals to 2 sine c plus d by 2 sine a minus b by 2 h into cos of x. Write down the formula, cos c minus cos d minus 2 sine a plus c plus So we can write it as limit h tends to 0 minus 2 sine x plus h by 2 sine minus h by 2 upon h cos of x. Now separate the limits. We can write it as limit h tends to 0. We want the term minus h by 2 here, so negative here. So multiply and divide by 2. This 2 will get cancelled. Put the limit sine x plus 0. This is equals to 1 upon cos of x. Sine upon cos is tan x. Next one is f of x is e power root of tan x. F of x plus h will be root tan x plus h. Now put these values in the formula. E square root of tan x plus h minus e square root of tan x upon h. Now take e root tan x common. Limit h tends to 0. There is no term of root tan x, so subtract root tan x minus 1 upon h. Limit x tends to 0. Ex minus 1 upon x is 0. 1. Therefore, we have to multiply and divide by this term. E root tan x, limit h tends to 0. E square root of tan x plus h minus square root of tan x minus 1 square root of tan x plus h minus root tan x. Multiply and divide by this term. Minus square root of tan x upon h. Now this term will be equal to 1. So e root tan x into 1. Limit h tends to 0. Square root of this term. Now we will have to rationalize it. Tan x plus h minus root of tan x upon h. Rationalize it. So we will have to multiply it by tan x plus h plus square root of tan x. Square root of tan x plus h plus square root of tan of x. Now in the numerator, a plus b, a minus b. A square minus b square upon h into square root of tan x plus h plus square root of tan of x. Clear up to here? Now we can write it in the form of sine and cos. Limit h tends to 0, sine x plus h upon cos of x plus h minus sine x upon cos of x upon h square root of tan x plus h plus root of tan x. Now take the LCM. E root tan x, limit h tends to 0, sine x plus h into cos of x minus sine x into cos of x plus h upon cos x plus h square root of tan x plus h plus square root of tan of x e root tan x. Separate the terms here. Limit h tends to 0. Sin x plus h sin x plus h now this is the formula